right, one more example problem. You pull a simple pendulum of length 0.245 meters to the side through an angle of 3.5 degrees and release it. How much time does it take the pendulum bob to reach its highest speed? Now, just FYI, pendulum bob means the mass at the end of the string. So again, they've told us we have a simple pendulum. That means string of negligible mass, all the mass is concentrated at the end. We've pulled it through a very small angle to 3.5 degrees and release it. And so it will swing back and forth. We know the length of this string is 0.245 meters. This angle, this is the maximum angle, 3.5 degrees. And we want to know how much time it takes for this pendulum bob to reach its highest speed. So if we think about it, we know that the pendulum will start with all potential energy initially. As it swings downwards, at its lowest point down here is when it's all kinetic energy. So the maximum speed occurs as it swings through its lowest point. So we're trying to find out how much time it takes to go from that maximum point to that minimum point. Now, as far as our equations go, for a simple pendulum, we have the equation that omega is the square root of g over L. We know omega in general is equal to 2 pi f. Since f is 1 over period, we can also say that's equal to 2 pi over t. So the period of this simple pendulum is something that we can calculate. We know the length, we know g. So let's go ahead and plug these numbers in. So 0.245 meters over 9.8 meters per second squared. The period of this simple pendulum. I'm plugging it in. I'm getting 0.9935 seconds. And again, I'm keeping more digits than what are given so that I can minimize rounding errors. Now, this is not the answer to this problem, but we can get the answer and reason out what the answer is. If we think about a pendulum or any oscillator, if we were to graph for a pendulum, for example, the angle it makes as a function of time. Here we've pulled it to the side to this 3.5 degrees. We release it. It's going to start oscillating like this. We know the period is the amount of time it takes for the pendulum to go from one point in its motion to the next time it is at that identical point. So if I come back to my picture, that means the pendulum swings down, swings up to the other side to its maximum angle on the other side, and then it comes and swings back down, swings back up, such that it's back to this initial position. That is one full oscillation. Well, a whole period, I don't know if you can tell, this is broken up essentially into 4 pieces. Segment 1 is going from maximum potential to kinetic, maximum. Section 2 is maximum kinetic back to potential. 3 is potential back to kinetic. 4 is kinetic back to potential. If we want to look at that on the graph, we know that an oscillator is going to be moving fastest when it is passing through its equilibrium position. Then it gets back to maximum potential, maximum kinetic, maximum potential. this period is broken into 4 pieces. So to go from its maximum potential to maximum kinetic, this time is 1/4 of the period. So 1/4 of our period, and then we have 3 sig figs, 0.248 seconds is the amount of time it will take to go from its initial maximum location, angle, and get to its maximum speed.